hot end socks that save you from the forbidden Pepto-Bismol, solder joints that aren't soldered, and more bamboo bed blunders just to piss off the Facebook groups. All this and more, Print Fix Friday, episode 58. Let's get into it. Hey, welcome back to the channel. If you are new here and you like looking at print fails and potentially how to fix them, make sure to leave a like and get subscribed. We go over these every single week. We are on week 58. I would believe we are the longest print fail fix video series here on YouTube. And remember, we're looking for your fails. If you got some fails you want us to take a look at, you can tag us on all the social medias. Links will be on the screen, as well as use the hashtag PrintFix so we can find it. But we know that failure is unfortunately always an option. And when you are playing at the bleeding edge, sometimes you get bit every now and then. But what won't bite you, without your consent of course, is our sponsor, 3D Musketeers. If you are tired of print fails and you want to get just some experts to help you out, even though we do have our own print fails, stay tuned. You can reach out to the pros at 3D Musketeers. We might have our own fails, but we don't make them your problem. We have 40 printers to help you make what you need to make for the products that you need them for every single day. And if you're looking for high-end 3D scanning, in fact, we did a lot of 3D scanning at the East Coast Rep Festival. Video on that soon, TM. Don't know how we're going to do that, but it's going to be a thing. You can reach out to us as well now with more 3D scanners. Videos on those coming also soon, TM. There's a lot of videos in the queue here. But either way, we appreciate any support that you guys can give us financially, if through a YouTube channel member or Patreon. A couple of bucks absolutely helps to making that creator fund a little bit better every single month, because it's still a loss leader for us. And well, if you're not in the mood to spend a couple of dollars, I understand. Like and subscribe, and a share goes a long way to helping the channel grow. Even if you are going to share it on Facebook and have a bunch of people personally attack me. Views are views, right? Anyways, let's stop talking about Facebook fails. Let's get into print fails. First up, we got a fail from a buddy of mine, Chris Riley of Chris's Basement. We'll link to his channel in that description. If you don't know Chris and his basement, go check him out. Very, very good content creator. And he's got a slice engineering boot that saved the day. This is why I talk so much about putting silicone socks on printers. In fact, it's one of the only mandatory upgrades for me on a Prusa Mark III's or even a Prusa Mini. Put a damn sock on it, because a blob of doom can a lot of times be alleviated by the sock itself. We can see the hot end, pretty darn clean. You know, a little bit of mess here or there, but nowhere near as bad as it absolutely could have been, covered in this pink craziness. And this is why silicone socks, to me, are pretty much a mandatory requirement. If your printer does not come with one, you can always buy them, or there are likely files out there where you can print your own molds and then go ahead and inject red RTV silicone, which I have done in the past. I've got here a silicone sock for the hexagon hot end from Lulzbot. It's what the Lulzbot Taz 6 came with bone stock, and they don't make socks for them. And so actually, one of our own staff members, Pyroball PCBs, will link to his information and some of these parts in the description down below, actually took the time to make molds. Don't be like me. Make sure to put mold release on it. If you're tired and you're doing silicone molding, you're gonna have a bad time, because I only have a finite amount of these left. F's in the chat. But I'll tell you, pretty much you don't need to change them very often. When they work, they work. And when they save you, they're absolutely worth their weight in gold. Because again, one of the big things we've been talking about here is time is money. If you can reduce the amount of time that you need to spend on something, well, then you're going to increase your profit margins every single time. And that even comes down to maintenance. If you have a silicone sock and it keeps you from having blobs of doom, then you've saved yourself hours of hard work. Moving on, we got connectors getting desoldered. We can clearly see a connector that has no solder on it. And I don't think that's going to be because the pads are getting hot and the solder is flowing away from those pads. I literally think it's because whenever this was assembled, it was assembled terribly. And what ultimately occurs here is that the solder didn't wick itself onto the pins of the actual connector. We can see that it's bent as well. None of this looks right to me. I would look at reflowing this personally, but this could have been caused just from stress over time. But I still don't think they had a good solder joint there, period. I am a little concerned about those pads lifting up because it definitely doesn't look great. But we can see that apparently this is a known issue on TiVo tarantulas, but I don't think this is a TiVo tarantula. And unfortunately, I don't see any information about their machine or what they're using, but it is possible, technically speaking, with enough resistance, you could build up enough heat to cause this to occur. But I think you'd melt your connector well before you'd start melting the solder joints or the pads themselves. So take that with whatever grain of salt that you want to take. This is a pretty easy solution to me, but a problem that should have been caught on the early side. I don't believe that this just happened. I believe that this was there for a while and likely was bought this way. When you buy from, let's go with cheap brands or brands that don't really have the best track record, make sure that you check the solder joints. This is a very easy thing to fix on your own. And if you are applying heat and you're not able to flow solder across those pins, look at getting a little bit of flux, or you can sand it. It might work. Sometimes it does, sometimes it doesn't. But honestly, if it's not something that takes months and months to replace, send it back and get another one. That is bad QC. That should not have left a factory. And if it is your printer causing this, look at your wiring, verify that you don't have on these PCB heaters a trace that is a little bit cut that could cause excess wear and heat to build up on the connector itself. How to solve this? Replace it or fix it. If you don't have a good soldering iron and you're not very capable or comfortable, I should say, doing it on your own, then don't. This is not a time for you to learn how to solder. If you want to learn how to solder, go get one of the dead electronics you probably have that you told yourself I'll eventually get rid of, but you never have, and learn on those boards from the electronics that are already dead, because there's no risk to you. Because what are you going to do? Break it more? I don't think so. You could try, but I don't think this is going to be worth the time. In my opinion, it's best to replace these, be on the safe side. Maybe keep it around as a spare and then learn how to solder it then. But because you've got 2 positive, 2 negative, and I'm assuming that's going to be your temp sensor coming in, you're going to have to put a lot of heat into this because the copper traces on the PCB heater are going to wick that heat away fast. This might be a case where I don't know if I'd even try it without a reflow system, and that can be a bit of a pain. Next up, a video from Mr. Chuck Hellebuck, otherwise known as Chep. You guys know him as Uncle Chep, another great content creator who has a BAMbu lab. And before the BAMbu lab fanboys come over here and start writing mean things in the comments, 1, hi, I'm in your Facebook group too, if you haven't noticed that yet. 2, I don't hate these printers. I just like showing when things go wrong. And if they're the ones that get 4 retweets and 35 likes and people can't figure out the problem, guess what? We're going to talk about it. I've had enough of the harassment from the BAMbu Lab people. I get it. I'm a Prusa fanboy. I'm also a Printed Solid fanboy, but that doesn't mean I hate other products. Anyways, let's take a look at this. 4,000 views, man. Jeez. If we don't know what's gone on here, we can have a general idea. The trigger for the Z-axis has not triggered. Again, I don't own a BAMbu Lab, so I don't know exactly how they deal with home, but I assume it's either with the LiDAR sensor or with some sort of inductive probe. And he has included BAMbu Labs, they would be able to see it. But unfortunately, no response. He's emailed the contact he has, he's cleaned the lens as requested, and still get this error, so something is wrong. It did print a semi-rough 3D benchy after setup, but I'll see if they have any further clues. It says, heat bed homing abnormal, there may be a bulge on, I'm assuming, the build plate. Micro LiDAR camera lens seems to be dirty, please clean the lens. First off, amazing that it gives you that, right? A lot of printers will just say, Z homing not found, or you know, Z not working, or it won't even notice that that's a problem and will just keep trying to ram into itself. My best guess here is that we've got a wiring issue, whether the connectors that are used, and I believe it's USB-C, is maybe a little bit loose or a wire didn't get soldered properly. these kind of things can happen. And I will give the BAMBU Lab team a lot of praise here because they've pretty much hit every deadline that they've said. And one, for a Kickstarter, holy hell. And then two, in today's industry, with the supply chain problems that a lot of companies deal with, holy hell, I'm impressed. But you gotta make sure that you provide good support to people. And sure, maybe Chuck could go to the Facebook group, but after the way that I get called out and personally attacked in there, I'm not exactly certain I can recommend it. Not that I ever recommend Facebook groups to people, but you know, hi Facebook users. But this sucks because there's not exactly a good option. If the wiring for that LiDAR system isn't working properly and it's not connected well, that could obviously end in the camera not functioning as intended. And yes, you can file a request in the GitHub, but I don't think, and I agree with Will here, that it's really the right place to do that. This would be a support ticket of sorts rather than a software thing, right? BAMBU Studio is software. This is, as far as I can tell, a hardware problem. But we can see Tom of Filament Frenzy, who loves his, and in fact has done some amazing prints with his BAMBU Lab. And he's messing around now with the 4-into-1 system so he can put up to 16 colors on his AMS. It does absolutely blow my mind what he's able to do with these. And yeah, lots of quality prints coming out of him. So make sure if you don't follow Filament Frenzy that you go ahead and do it, because he kind of knows his stuff. I mean, geez, this is a Prusa print, but good lord, that's beautiful. But yeah, BAMBU Lab, I'm rooting for you guys, but we do got to get some of these little things solved. This is not a big issue from what I can see. I've only ever seen a couple of other people with these before. Don't know if theirs were ever solved, but I'm sure we will hear more from Uncle Chep here so we can see whether or not this does actually get solved in what we would consider a timely manner. This is just part and parcel of dealing with growing a company. These QC issues are going to happen, and there's really no way to get all of them. And unfortunately, we don't have any updates, but you know, if nothing else, we've got a sick beat. Anyways, let's move on. This one comes from one of our Patreon supporters, 5HFR. One of their coworkers has an elegant solution to a pretty ridiculous problem. This printer came in as it was not functioning, and when they checked the firmware, the E-steps on one of the axes was set to 3. Not 30, not 300. And if any of you have dealt with these melzi style boards and having to go through and turn it to get the E-steps up to where you need, it bloody sucks. Chuck a drill on there, and honestly, blows my damn mind. That's an Occam's razor thing, right? It's a completely stupid way to solve it, but damn it, it's a simple solution and it works. So I love that. Actually, I would condone the ever-loving hell out of that. But be careful with these melzi 8-bit boards, because if you turn it too fast, it doesn't register. And if it does, there's a lag on it, and it can be a real problem. So do that one at your own risk. But if you do need to go from like 3 to, well, at least 145 from what I can see here, a drill's not a bad option to get you there. I dig it. Next up, I got a personal fail here. It's not often that I show off some of my personal fails, and in fact, there's one occurring right behind me right now. Some of the support material has failed, and you might be able to see there's some pieces that are definitely not support material. I have added sacrificial parts, like just failures that I keep around for this exact reason, and melted them into the support towers that already exist in an attempt to get the support to fix itself, because all of these parts are carbon fiber, and carbon fiber, 1, it's an absolute bear to print, 2, very expensive, and 3, you cannot print it very fast on a Prusa, simply because if you do, you have a high chance of getting a clog. Now, I am using a Diamondback nozzle, and by the way, I got a box from them, and it includes some really cool things, like a vial of the polycrystalline diamond powder, and a multiple carat slug of that polycrystalline diamond, and rubies, you know? So if I wanted to have just one rose-colored glass, well, I could. If you guys want to see me, you know, scratch some stuff and look at some of the cool features of polycrystalline diamond, let me know. It was cool meeting Mark and Harris at the East Coast Rep Festival. They found me after the Maker That Money live episode and yelled at me to get my attention, and we took a couple of photos, and they were there passing out nozzles to people, trying to spread the word of the diamond nozzles. They sent me some more care packages, so thank you guys for the nozzles. They've already gone to good use. I threw a 0.6 on the Prusa behind me, and right above me, the Fusion 3 up here just got a 0.6 Volcano diamond nozzle, and there's some R&D loveliness in there, so thank you guys for all of your support. But even the diamond nozzles can clog. I've dealt with a couple of small ones so far, but it's a lot less problematic on the 0.6 than it was on the 0.4. The nice thing is I can just use a steel acupuncture needle and I will not damage the nozzle tip. That's the big thing about why I'm against those steel acupuncture needles, because normally on a brass nozzle and even some steel nozzles, the steel of the needle is harder than the steel of the nozzle or the brass of the nozzle, and therefore will cause damage. It is not harder than the diamond, promise. Cool feature there, but that is a bit of a fail. And I did have a further print fail. This is a part that we're making for a client, and we got lots of zits. Coming to find out, the roll of carbon fiber PETG that has definitely been rewound, that I did put carbon fiber nylon on, but definitely extruded perfectly fine. This is a 215C on a diamond nozzle. Definitely not carbon fiber PETG. It's probably carbon fiber nylon, and given that we were printing it at 215 degrees centigrade, I am bloody impressed, but clearly the nylon needs some tuning in. This is definitely a fail for me. We had a nozzle clog that happened right on the exterior perimeter, and when that occurs, no matter how quickly you can catch it and be able to clear the clog by doing a manual filament change and then trying to clean the nozzle itself, this is not salvageable. And when this is going on a really cool project that I will hopefully be able to share with you guys pretty soon, it's a robot, and that's all that I can tell you for now. If it's going on something like that, and it's a multi-$100,000 robot, it needs to be perfect or damn near close to it. And while the print probably still would have succeeded, it would have likely been more than strong enough, especially considering it's actually carbon fiber nylon. I don't like delivering product like that. The other thing that we did find out is I have been struggling with these S2 filament dryers. There's the one right above me next to our plush Taz right there. I found that no matter what I did, I could not get it to feed filament cleanly into the printer. And then I'm like, wait a minute, reverse Bowden. That's exactly what I did, and it works an absolute treat. You can see the Bowden tube running from the dryer right here into the Prusa behind me, and it's been working a treat. And now I can much more comfortably print out of that dry box, which is currently sitting at 65C, which is very, very nice. And we can definitely see the quality increase as we changed over to definitely carbon fiber PETG. The prints are looking beautiful. And in fact, here you go. That is another part failure, but that one was caused by a layer shift. You can see the layer shift up here. But yeah, absolutely beautiful surfaces with those diamond nozzles, because of course they iron as they print. Love it. But yeah, failures happen, and when you're under a time crunch, you're gonna do dumb things like that. Worst comes to worst, I lose another hour or two, but best case scenario, the print finishes totally fine, and I get to take some fun photos for the client. But that's the way things go sometimes with 3D printing. You have to improvise if you're under a time crunch. You'll notice all 4 printers behind me are running, and in fact, most of the printers in the shop are running. Hilariously, the Fusion 3 is not running because it is being used as a large dryer to dry out all of my other carbon fiber PETG, and hell, the nylon is in there too while we're at it. But the other Prusas are all running parts for clients right now because, of course, everybody needs emergency parts immediately. That will have to be a podcast topic that we talk about. Maybe we'll do it this weekend. I don't know. Let me know in the comments, because I still haven't decided on that. And I didn't book a guest. That's on me. So it'll be another solo episode. So let me know what you guys think down in those comments for future podcast topics, including one maybe for this weekend. But it is something that you have to be able to plan for. We don't have 40 printers because we always need 40 printers. We have 40 printers because every now and then you need to ignite your entire print farm, as well as some of the mildly suspect printers in your fleet, to make sure that you can meet deadlines for clients. Of course, you charge accordingly, because my time is valuable, and if I'm going to sit here and monitor printers 24 hours a day, it's going to be a little bit of extra cash involved. But yeah, let's move on to the next one. How do I stop end of path over extrusion? This is teaching tech's first layer test, but it happens with all of my prints. I also played with the Z-hop and it still happens. I also check my extruder, steps, and flow. So let's take a look at this a little bit more. It looks like you're too close, but this is a Bowden printer. And I have an idea of what's going on. Exactly. It is linear advance or pressure advance. We've talked about this before, and it's been a little bit, so let's talk about this again. Linear advance and pressure advance. It is something that plagues Bowden 3D printers, even if you're using some of the high-quality Capricorn tubing that I love, and they've sent me over a few kits. It's pretty fun. And there is behind-the-scenes content with Capricorn for our Patreon supporters, or there will be soon once it's finished edited. So if you don't support us on Patreon, kick a buck or two into that creator fund. That gets you access to all the behind-the-scenes content, including lots of extra footage from Earth and other things. But what occurs is, as the filament goes through the path, it is under pressure. And no, not ice, ice, baby. It's under pressure. And I know they're tough to tell. It's fine. When that system is under pressure, even when you stop extruding, you will still run into problems where, potentially, you've got back pressure in your system. So even if you're not extruding anymore, there's still some buildup of pressure that is going to come out of your nozzle. This is handled in one of two ways. If you're in Marlin, it's linear advance or pressure advance if you're in Clipper. And I know RepRap firmware has its own way as well. It's all some form or another. But what it basically does is it will either stop extruding before it finishes the part, so basically a coast, or it will even retract at the end of every line. And if you have a short Bowden system, that's totally fine to do. But on printers like our Fusion 3 above me that has a 1 meter long Bowden tube, it's not good. We use a couple of other functions and features like speeding up and slowing down at the beginning and ending of the lines, and that generally handles it for us. But this can all be tuned out in Slicer. Pressure advance or linear advance is absolutely the right option here. Now, what to put in? I don't know. It is absolutely specific for everybody's use cases. However, if this is a stock Ender 3 and someone gives you a number that they used on their stock Ender 3 and it worked, try that first. Thankfully, it's not too picky and it's very, very easy to change and then push back to the machine. In fact, I believe it's a G-code command that you could put in your start code so you can easily mess around with it until you're happy and then either bake it into your start code or bake it into the EEPROM itself. For me, I like leaving my printer firmware as stock as possible, and any little fun features that I might add, I do on the start code side of things. And they also don't need basically any cooling, which is always a nice feature. I cannot figure out what's going on. This has been happening for about a week and I can't figure out how to fix it. More details in comments. Ender 3 Pro, brand new spool of inland PLA plus 220 on the nozzle, maybe a little hot, but it's within spec. 60 on the bed. I truly don't know where to go from here. I've cleaned my Z-rod, used some PTFE grease, and redid the whole Z-axis. Checked all my eccentric nuts on each axis, bed leveled, and using a BL Touch. Okay. Lately, I've been hearing a rumble sound and can't tell if it's coming from the X or Y stepper motor. Not sure if it's my slicer setting either. I'm pretty much using the same settings as I always, with minor tweaks depending on what I'm printing. Probably fine. Help is greatly appreciated here, as I'm at the point where I'm about to just buy a whole different printer. Seems like this one has been nothing but issues for me. Could also be user error, but I'm just completely stumped here. I have got the exact same question. Is it the top or the bottom? I'm also assuming it's the top. I believe we're actually running into some binding. And whether that is extruder binding or not, I don't know. In fact, I'm pretty certain it's Z-axis binding. We can see that it is starting to over extrude here, and this would align perfectly with Z-axis binding. If you've cleaned and lubricated your Z-axis, great, but if your Z-rod, for some reason, is warped, or maybe you've got a bad bearing on your Z-axis eccentric nuts. A lot of different options there, but this is absolutely a binding issue from my perspective. If you think I'm wrong, let me know in those comments below. But it looks like he's just printing on top, on top, on top, on top, on top, without moving at all in the Z-axis, and that, to me, indicates a binding in the Z-axis itself, because otherwise, it actually looks pretty good. Those lines look good. We got a weird color issue here, but I don't think it's that big of a deal. I'm definitely leaning toward Z-axis binding. Let me know what you guys think down in those comments below. Why does my first layer look like this? PLA at 210 and 60.4 nozzle, 1.6 layer height. Well, there's your problem. Looks good into the corner, then it starts lifting. Oh, 0.16. Okay. Got it. It's gonna say, that's not gonna work. That's way too big for that nozzle. All right, 0.16 makes more sense. We definitely have a bed tramming issue. Go back, retram your bed, and life should be good. It could somehow be related to cold, but if it's PLA, it's probably not, in my opinion. But this to me is just a warped bed, and you're dealing with some tramming issues. It is common for Ender-style printers when they have that carborundum glass plate. If you are holding it at the four corners, those will likely be lower than the middle. Glass is technically a liquid. It just moves very slowly, and it can bend ever so slightly, and I think we might be dealing with that here. If they're not using a glass plate for some reason, then I would absolutely hedge a bet they have a warped bed. Personally, if you are going to print on glass, I like mirrors, because mirrors generally have to be very flat. And you can tell very quickly if they're not, because the reflection in the mirror will be distorted as well. But because I don't know the printer, I'm not exactly able to move much forward. And it looks like cranking the bed up to 75 did solve their issues, and they're asking their wife for one of those pop-up jammies for Christmas. Now, what they really mean is like a Wham Bam hot box, and of course you can use code Musketeers 2022 for 10% off through the end of the year. And Wham Bam did just release some pretty cool products, one of them being a fire extinguisher, and there might be a few on their way. And I might still have that printer that we lit on fire a while ago. I think you all know where we're heading with this. I got nothing to lose. Let's have some fun with it. But if it is really cold where you are, it might help to just physically heat up the air a little bit more. 75°C is very hot for PLA. In fact, it is beyond the PLA's glass transition temperature, which means above about 65°C, PLA will start to get soft. And when it's soft, it might still have this issue. You just won't see it because it is functionally laying flat because of all the extra heat. I would also look to make sure that your bed is not oily or has any gunk on it. It's always good if you're going to go through and retram your bed that you also go and clean whatever material it is that you're using for a plate. Hope that helps. But that is all I have for you guys today. I hope you all have been enjoying the East Coast Rep Rap Festival content. There's another video coming out next week of day 2 at IRF, and then the week after might have something to do with this shirt. But stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one. It was cool meeting. Hey, thanks so much for watching this video, and a massive thank you goes out to all of our Patreon and YouTube channel member supporters. You guys are awesome. Thank you for being a part of the Musketeers. And of course, the $5 tier and higher, your names will get listed right next to me in this outro. Right below me will be the entire PrintFixFriday series, and next to that will be our coverage of the East Coast Rep Rap Festival. I will see you guys down in those comments, and in the next one, take care.